All right, friend, keep tracking with me. Stay in this with me. It's going to get crazier. So let's buckle up. Hello, my loves. Welcome back to another episode of the B is 4 podcast. I'm your host, Bria, and today I am introducing a new series. Insert round of applause. I feel like I need to give you all a little bit of context. We have a running joke, me and my friends, about me being the woman version of Bill Nye the Science Guy. Literally, my friends call me Bria Nye the Science Girl. And I feel like to adequately explain this, I need to give you this context. So I'm going to show you a clip of me and my friend Braylon and her roasting me, but like hilariously roasting me, so that you can understand where the series is coming from. So here's the clip.
My Bria boo, my pookie. She is so smart, y'all. Any questions that I ask her about anything, she's like, actually, and she'll put on her bifocals and she'll be like,
Bifocals is crazy, Braylon.
She'll be like, in 36 BC, before the emancipation of the earth, actually there was a man named, he was Mormon, and he started farming, and when he got the grains, women were actually in the household, and the women had, I'm like, Bria, literally all I asked was, what do you want for dinner? She's like, but I'm gonna bring it around because actually what I want for dinner is what they were farming back in 1860 BC. Because if you really think about it, the circular is perpendicular. She's like, and she be knowing I'm dumb. Not dumb, I rebuked it, I'm not dumb. But I'm not dumb, but she be knowing I don't know. She'd be like, the circumdicular means circle. She'll explain her words, because I'm like, bitch, now you know. I'm looking like, what are you talking about? I literally just asked this girl and I knew she was gonna know the answer. I'm like, there was a rainbow outside of my house. I'm like, what's a rainbow, Bria? She's like, a rainbow is actually when the water perspires. It perspires off of the sun, and the sun rays hit the clouds, and when the clouds actually have a lot of perspiration. I'm like, bitch, how did I know that you would know the answer to this? Do y'all know what a rainbow is? I know you don't, dummy. But she does. She knows the true definition of every freaking thing. What did I ask you earlier? You're talking about farming. I was like, why does this happen?
Daylight savings.
I was like, yeah, she's like, we springed forward. I'm like, yeah. It's like, what is daylight savings? Why do we need that anyway? It was just a throwaway. I did not need her to answer it. It was a rhetorical question. I was just like, whatever. She goes, actually, daylight savings started when farmers back in 36.9 BC, .265. I'm like, Bria!
Why do you make me sound like Urkel?
Well, according to my calculations. She doesn't sound like that, but that's how I feel like what comes out of her when I ask her questions.
Oh my God.
She's so smart, y'all. She's so smart. She's one of my smartest friends.
Oh my God, Braylon.
You just know so
This
much.
is my funniest friend.
She knows so much about everything.
Okay, so now that you've seen the clip, it's hilarious because all of my close friends responded to that when I posted it, and they were like, oh my God, this is so you. You do sound like that. Like, I have like a weird knowledge bank. Like, I will remember a random fact about space, but I literally won't remember what I ate for breakfast. And so I love learning. I think it's so fun. I was always quote unquote good at school, but I didn't actually enjoy what I was learning about. And I think it was just because of the way that it was taught to me. As I've gotten older, I've learned how to learn. I've learned that hearing things described in different ways by different creators, by different people who teach in such a unique or more fun way, I learn so much more. And I've also just gained an interest in a lot of different topics that kind of piqued my interest when I was younger, but I've really leaned into as I've gotten older, like history, science, psychology, sociology, anthropology. And so as I continue to learn, I think one of the most valuable ways to solidify the way that you learn is to teach. So whatever you learn, teach it to someone else, and it sticks in your brain so much more. And so I figured, okay, if I'm learning and there's things that I'm hyper fixated on and I just find really interesting, why don't I share with the pod? But also, I feel like it's a good opportunity for all of us to continue to learn. I feel like American history is not always written accurately. And so I am solely doing this because it's genuinely so fun for me. Like, I'm giddy right now preparing for it. The series is called Things Worth Knowing. Every 5 episodes is going to be a Things Worth Knowing episode, and it's going to be a different topic every time, and we are just going to go on a little learning lesson together. And I'm not sitting here acting like I'm a professor or like I'm a teacher. I'm just sharing the things that I've learned, and I feel like it'd be cool for you to know as well. So today we are talking about my favorite topic. If you know me, you know that this is like my hyperfixation. I am obsessed with all things space, universe, astronomy, astrophysics. Yeah, I just love it. Like, I cannot learn enough about space and the universe. And I feel like once you kind of start to expand your mind and open your mind to it, there's so much more that you want to know. It is wonderful and it is mysterious and it is captivating, and the science makes it that much more cool. So we're going to talk about the universe, but I have to give you some context as to why I'm obsessed with the universe. The answer is I don't really know. I just have been since I was a kid. So when I was little, I was obsessed with the moon. So for starters, my mom always called me Star, short for like a cute nickname that she has for me, Bria Mookie Star. Cute mom. Which is funny because now I call everybody like Pookie. Well, she called me Mookie Star. I've always been obsessed with space because I always heard that nickname growing up and I was like, I'm a star. Like, and I envisioned myself like a little gas glowing orb in the universe. Not like actually gas, but like I just thought it was a star. I thought it was really cool. And I was obsessed with the moon. And so every night I used to ask my mom and my dad, I'd be like, yo quiero buscar la luna. Like, can we go outside and look for the moon? I want to look for the moon. And La Luna, I think, was like one of my first words, literally. Like anybody in my family will tell you, I think La Luna was like one of my first words. My parents would take me outside and we would go look for the moon. And anytime it was a new moon or the clouds were covering the moon or we simply couldn't see the moon, I would literally cry. Like I would be so upset that I couldn't find the moon. And I just was infatuated with it. So when I was a kid, like, you know, those little like glowy stars that you used to put on your ceiling, I had those. I had like this gift. I got it at the Science Museum in Miami, if you know, you know. And it was like this moon and it was a lamp. And you would change with the button on the lamp what phase of the moon it was. So like I had this light up moon in my room and like each night I would like change it to the different phase of the moon. Damn, that just like unlocked a crazy core memory for me. But yeah, always was obsessed with the moon and space and like what is outside of Earth. And so to preface, this has just been something that I've liked since I was a kid, but now as an adult, I've taken more time to actually lean into and learn. And so you will catch me on a random weekend binge watching YouTube videos about astrophysics. Like me and Neil deGrasse Tyson are friends. He just doesn't know it, but we are. So I wanted to talk about the universe. I wanted to talk about space on this first episode of Things Worth Knowing. So let's just get into it. I'm going to start with that approach, right? Of like you stand on the earth and you look up at the night sky, and from our point of view, to the naked human eye, we can only see about 3,000 to 4,000 stars in the night sky. And that is if and only if it's a new moon or it's not a full moon, because the light of the moon will almost fade out any stars that are around it. And you also have to be in a location that doesn't have a ton of light like pushing up towards the sky to make it harder to see the stars. So like on average, you're only seeing like 300 to 400 stars in the night sky with your naked eye. But then in better conditions, 3,000 to 4,000. So like when I was in Hawaii, Because we're on a rock in the middle of the freaking ocean and you're looking up at the sky, there's not a ton of light and reflection pushing off so where you can't see the stars. So you see so many stars. But if you're in LA and you look up at the sky, you're only going to see a few, right? And so that's all your naked eye is able to see. That tiny number, the 300 to 400, or even the 3,000 to 4,000, is the tiniest bit of what is actually in the universe. Let me put this into perspective. Scientists estimate that there are 2 trillion galaxies in the universe. Not stars, not planets, galaxies. And if you're not familiar with what a galaxy is, you might be familiar with the Milky Way, which is the galaxy that we are in. Inside each one of those 2 trillion galaxies are an estimated amount of 100 to 400 billion stars. Billion with a B. So there's 2 trillion galaxies, and within each of those galaxies, there's 100 to 400 billion stars. Our brains cannot even comprehend anything of that size and scale. Like, I cannot fathom that many galaxies and that many stars. But let me give you an example of our galaxy, the Milky Way. So obviously we've heard about this when we were a kid. We're like, oh, the Milky Way and Orion's Belt and all the things. In the Milky Way specifically, there is estimated 100 to 400 billion stars. If you looked at the Milky Way and you counted every single star, 1 star per second, it would take you 3,000 to 12,000 years to count all the stars that are in the Milky Way. What? Like, that is insane. Another way to put it is there are more stars in the observable universe than there are grains of sand on the entire planet Earth. Not just beaches, but deserts. There are more stars than individual grains of sand across our entire planet in the universe. That's insane. All right, friend, keep tracking with me. Stay in this with me. It's going to get crazier. So let's buckle up. So it turns out that most stars, we believe, have a planetary system orbiting them. So if we're talking about, let's say, 400 billion stars in the Milky Way, and all of those stars at least have a few planets orbiting them, that's a whole lot of planets. There's an estimated amount of 10 to 40 billion that are potentially Earth-sized and habitable. Being able to detect and look at planets in other solar systems is really hard to do even with the technology that we have now. Because with the telescopes that we use, the brightness of the star tends to outshine the planets that are orbiting it. So if you were on one of those planets looking at our sun, it would be really hard to see the planets orbiting the sun because the sun is so bright. We're able to observe galaxies outside of the Milky Way, but it's much harder to actually observe planetary systems surrounding the stars that live within that galaxy. I know it's a lot. Okay, so let's make a little funnel. There is a galaxy, aka the Milky Way. Within that galaxy, there's billions, hundreds of billions of stars. And then around those hundreds of billions of stars, there's planetary systems that are orbiting them in the Milky Way alone. And there's 2 trillion galaxies, meaning, oh my God, I can't even do the math. That's insane. So an interesting example of a potentially habitable planet, there is an exoplanet called K2-18b. And this planet is one of the closer planets that we're actually able to observe. We can't fully see into it, but we can see the gases that surround it and what the atmosphere is made of. And scientists believe it's what is called a Hycean world, meaning it may have a really hydrogen-rich atmosphere, a massive global ocean, and warm temperatures. Those are all conditions that very likely can support life. And the starting of Earth was not too far off from that. But that planet is 124 light years away. It would take us millions of years to reach it. So let's talk about light years, because if you don't know what a light year is, it's really hard to conceptualize how far things are in space. A light year is essentially the unit of distance, the amount of time it takes for light to travel from one spot spot to another. It's the distance that light is able to travel in 1 year. And we go off a Julian year, so 365 days. Light moves at about 186,000 miles a second is how quickly light moves. 1 light year equals 5.8 trillion miles, meaning we are seeing an image of that planet from the past. We're seeing it from 124 years ago, because that's how long it took the light for that planet to come into our observation. So crazy. Now that we have like an idea of spatial distance, right? Let's talk about the size of the galaxy that we're in, the Milky Way. Our galaxy, the Milky Way, is 100,000 light years across, okay? That equals 587 quadrillion miles. Now, I know what you're thinking, like, Bria, I can't even conceptualize 587 quadrillion miles. Honey, I can't either. So I'm going to give you an analogy so that we can try and wrap our heads around this, okay? Stick with me. It would take us in a commercial jet to get from one end of the Milky Way to the other 150 billion years. Now, we have evolved science and we created this incredible space shuttle called the Voyager 1, which is the fastest spacecraft ever invented. That spacecraft goes 38,000 miles per hour. So think about our measly little airplanes that go like 550 miles per hour to the Voyager 1 that goes 38,000 miles per hour. Okay? It's like, I don't even want to do the math on how much faster it is than a commercial airplane. You get the gist. If we were in the Voyager 1 and we went from one end of the Milky Way to the other, it would take us 1.7 billion years to cross the entire Milky Way in the Voyager 1. Like, that is how big the Milky Way is. Now let's zoom out. The Milky Way is one galaxy, and there is believed to be in the observable universe 2 trillion galaxies. The universe is so vast we cannot even comprehend it. Like, it's insane. That is insane. There's so much out there that we just have no idea about. And like, we're able to see it through telescopes, but like, what? There's 2 trillion galaxies, and it would take us in a Voyager 1 1.5 billion years to get across our galaxy alone, let alone 2 trillion of them. Dog. If that is not so cool, I don't know what is. Like, what? That's around us, friends. Like, that is real. Like, I don't think that we realize how vast and crazy and incredible space is. Okay, but if that is all too big for you, if you're like, Bria, I am hardly tracking, like, that just blew my mind, I'm lost, like, where are we in the universe? Let's reel it back in to our solar system, okay? So NASA created something called a space probe, and a space probe is an unmanned spacecraft that we send into the atmosphere to observe other parts of our solar system that we cannot send humans to go observe. These probes travel around 40,000 miles per hour. So 2,000 miles per hour faster than the Voyager 1. So they're really, really fast. At those speeds, this is how long it takes a space probe that moves 40,000 miles an hour to get to each of our planets. From Earth to Mercury, a space probe would take about 3 months. From Earth to Venus, a space probe would take about 3 to 5 months. From Earth to Mars, a space probe would take 7 months. From Earth to Jupiter, a space probe moving 40,000 miles an hour would take 6 years to get to Jupiter. To get to Saturn, 7 years. To get to Uranus, 8 to 10 years. To get to Neptune, 12 years. So if you think about it, with today's technology, we actually could get a human to Mars. Like, we could put a human on Voyager 1 and we could get them to Mars in 7-ish months. The problem is we have nothing to refuel at Mars. We have no resources to get people back. Technology is not advanced enough for the return trip. So it actually would be pretty easy to get them there, but we could not get them to return home. So it's crazy to think that even in our own solar system, it would take us in the fastest spacecraft that we've created, still like 12 to 13 years to get to the furthest planet in our solar system. Imagine sitting in a spacecraft for 12 to 13 years just to get to the last planet in our solar system. And then the only way that you can get back is hopping on a spacecraft and getting back in another 12 to 13 years. That's like a 24 to 26 hour or 24 to 26 year round trip. That's like almost my entire lifetime. Like, that is insane. And that's only our own solar system. That is how much space there is between us and even the planets that are in our solar system, let alone the solar systems that are in our galaxy. Let's talk about how we even know about any of this. So you may be thinking like, oh, did a person just sit on Earth and look into the night sky and figure all this stuff out? And the answer is hell no. There are humans that obviously started looking into space and then developed really incredible technology, such as the Hubble telescope and the James Webb telescope. So the Hubble telescope was launched in 1990 and it was revolutionary to astronomy. It actually helps scientists determine what they think is the age of the universe. It also allowed for us to see that there's an existence of other galaxies outside of ours. And it provided strong evidence for black holes. So in my mind, I'm like, the Hubble telescope walked in order for the James Webb telescope to run, babe. Think about like the first iPhone you ever got and then the most recent iPhone. Like, that's the type of upgrade it was. So the James Webb telescope was launched more recently, and it's literally the most powerful telescope ever built and known to mankind at this point. It literally allows for us to see through cosmic dust and observe extremely distant galaxies. Some of the galaxies that the James Webb telescope has observed are a few 100 million years after the Big Bang. So like, we can see really far into the universe. Okay, so let's talk about one of the most fascinating things to me, which is black holes, because they're like the least understood, least known thing in the universe. Like, we have no way to actually study it because of the essence of it itself. So let me explain. I'm sure that you've seen black holes in movies and you're like, oh my God, a black hole, wormhole, like combust and it's never gonna come out and like all this stuff. And it's like, yeah, how it goes, but like not as intense as how it actually is. So a black hole is started when like a massive star collapses under its own gravity. The gravity of the black hole is so strong that not even light can escape it. Pulls even light in, which is insane. It's so hard to like even understand. So fair warning, you're not going to understand it in this episode because scientists don't even fully understand it yet. I would love to. I hope in my lifetime we like figure that out. But the best analogy that I can give is, imagine that there's a massive drain at the bottom of the ocean and it is just sucking in the ocean. When you are kind of around it and not directly in its force, but there gets to a point where the force is so strong that all the pressure from the water, all the pressure pushes you and pulls you straight down that drain. Like, think about just like water into a drain at the bottom of the ocean, and it's literally like the force of the entire ocean going into that drain. That's like the best way that I can describe a black hole. Holes are so massive that they literally bend space and time. The stronger gravity is, the slower time is. I don't know if you've seen the movie Interstellar. It's literally my favorite movie. So if you haven't seen it, I highly recommend it. But they go on a space exploration and they go to, I believe, Miller's planet. And they're warned that the gravity on Miller's planet is so strong that when you actually get to the planet, I think it's like 1 hour on Miller's planet is equivalent to 10 years on Earth. That is actually science. Like, if gravity is super, super strong, it slows down time. So a black hole literally bends space and time. So fun fact, the closest black hole that we can see is the one that's actually in the Milky Way. It's called Sagittarius A. And that black hole in the Milky Way is the equivalent mass of 4 million of our sun. It's massive, and it's in the center of our galaxy. And most galaxies that we observe have black holes in them, not just in them, but at their centers. So crazy. So it literally pulls and moves everything. So wild. And then there is dark energy and dark matter. And I don't want you to hear those words and be like, ooh, dark, negative energy, bad. No, like, get that negative shit away from me. It's not what we're talking about. Dark energy and dark matter is literally the space in between what we're able to observe. And we have yet to truly understand it. We know almost nothing about it. It's literally the biggest mystery in physics. Everything that we can see, so planets, galaxies, stars, only make up 5% of the universe. About 27% is dark matter, and about 68% is dark energy. And we know nearly nothing. Dark matter is completely invisible, but it has gravity because it holds galaxies together. And dark energy appears to be causing the expansion of the universe. So scientists have found that the universe is actually expanding. Like things are moving away from each other. It's like continuously growing, meaning that most of reality is made up of things that we don't fully understand. We actually only understand like 5%, which is nuts. I'm like, can we like speed this up? Like, I want to know what dark energy and dark matter is. Like, how do I study it? How do I figure out what it is and how it operates? And it's just like, how do we only know about 5% of the universe? Crazy. It's like that quote where it's like, the more you know, the less you know. The more that I learn, the less I know. I'm like, okay, so what does that mean? And then there are no answers. I don't know. Maybe this will spark a future scientist who ultimately ends up figuring that out. Power to you. I am not great with formulas, so I couldn't actually be a physicist, but I love to study physics conceptually and see how it impacts the world around us. So if you need someone to like unpack your thesis statement and see how it, impacts us as a society, I got you. Doing the actual physics, like the equations, you lost me, babes. I wasn't even that good. Math is not my strong suit. But that's crazy. Okay. So I could literally talk about dark energy and dark matter and black holes in a whole separate episode. Like it could be its own topic. And I am going to spare you from that right now because I will nerd out about it for another hour if you let me. Let's go back into our solar system and start to think about things through that lens. I want to give you a frame of reference that makes sense, at least in what predominantly surrounds us. If the Milky Way galaxy was the size of North America, our solar system would be the size of a coffee cup, and Earth would be a grain of dust in that coffee cup. Like our galaxy is massive, massive. But let's zoom into Earth because that is our home. That's where we live. I just want to give you context of how long this beautiful planet has been here, how it got here, and our footprint on this planet. So Earth is 4.5 billion years old. 4.5 billion years old. Okay, so let's separate the difference between million and billion. 1 million seconds is roughly 11 and a half days. It's almost 12 days. Let's call it 12 days. That's a million seconds. A billion seconds is 34 years. There is a huge jump between million and billion. Huge. Okay, so the Earth is 4.5 billion years old. It has been around for a long time. It initially started off as like a molten world of lava, so much lava. And then shortly after forming, a Mars-sized object collided, and debris from that collision all came together. Gravity pushed it together and it became our moon. So our moon is actually a derivative of the Earth. It didn't just like break off in a perfect circle, but it was all the debris that came from the Earth and then went into Earth's orbit and with gravitational pull became our moon. But at 4.4 billion years ago is when Earth cooled enough for us to have liquid water. So Liquid water, 4.5 billion years ago, almost a billion years later, was the first evidence of life. But this was really simple, single cell organisms. And life literally stayed microscopic for billions of years. Then, 2.4 billion years ago, so add a whole billion years, is when certain microbes evolved photosynthesis, producing oxygen, which ultimately air into Earth's atmosphere. And then almost a billion years after that, so there's air, there's water, there's photosynthesis that creates that oxygen. Then 1.8 billion years ago, so almost a billion years later of it being that way, complex cells called eukaryotes formed. And those are the cells, those are the more complex cells. They eventually evolved into animals, into plants, into fungi, into humans. So then, 600 million years ago, life starts to develop in our oceans. First signs of multicellular animals. Then, for 150 million years, the only life was in the ocean. And then we started to see at 470 million years ago that plants began to colonize land. So we're seeing a lot of greenery. And then another 70 million years after that, so 70 million years of just aquatic life and plants, we finally start to see insects and land animals. We see them about 400 million years ago. And they exist for almost 200 million years before dinosaurs come around. So 230 million years ago, dinosaurs appear. Like, dinosaurs dominated Earth for 165 million years. Dinosaurs were not just like a blip on the radar for a couple of centuries. They literally ran this planet for 165 million years. Then boom, asteroid hits Earth, takes them all out. Crazy work. They're over here like, bro, we've been here for 165 million years. How are you gonna take us out like this? But the asteroid sure did. But that was 66 million years ago. And then 60 million years go by, and 6 million years ago is the first time that we had record of human ancestors, not Homo sapiens. I'm talking Neanderthals, etc. So kind of that blend between, I'm sure you've seen like the evolution of a man where it's like an ape to a human. That like middle ground developed 6 million years ago. Then operated that way for about 5 million years until about 300,000 years ago, where we have the first record of Homo sapiens. First record of humans. And only 12,000 years ago, agriculture began. So like actual civilization started only 12,000 years ago, and the Earth has been around for over 4 billion years. And 5,000 years ago, so of the 12,000 years that humans have existed, only less than half of those years have we actually had written language and recorded history. Wild. So to give you perspective, if Earth's entire existence was in a book, and the book was thick as hell, 1,000 pages deep, human existence would be in the very last sentence on the very last page of that 1,000 page book. We are a blip in the totality of Earth's existence. It's so funny that the moon came from Earth, because Earth would actually not be habitable if it weren't for the moon. So the moon, because of gravity, stabilizes the Earth's axial tilt. I think it's like 23 point something degrees, and it keeps it stable. If the moon did not exist, the Earth's axis and the tilt would be so wobbly, it would range from like 0 to 60 degrees. So it would be super unstable. That instability would cause for insane, extreme climate swings. Like climate swings that would not be habitable likely by people, Homo sapiens. Could potentially be habitable for life, but very unlikely considering how much those climate swings, or how extreme those climate swings would be. So the moon actually acts as a stabilizer for the Earth. And that stabilizer allows us to have seasons, because it keeps it so stable at this axis that we're able to actually get consistent seasons. Therefore, life can grow, life can evolve, etc. Scientists actually believe that because of that, the tide pools that naturally were created likely helped ocean animals, aquatic animals, evolve into land animals. So if you've ever seen books back in the day, they were like, oh, like there were dolphins and they eventually like evolved into wolves because evolution, Darwinism. They feel as though the tides that were created due to the moon's gravity helped with that evolution. But it's funny because as we talk about the universe expanding, the moon actually is drifting away from the Earth, only like 3.8 centimeters a year. So it's not going that far. It won't go that far in our lifetime. But in a few 100 million years, it may be far enough to where the Earth is inhabitable because of how extreme the climate swings would be. But unfortunately, I have a feeling that humans will kill our planet before that does. Not to be a Debbie Downer, but humans found a way to accelerate the death of our planet no other species has done, or catastrophic event that's happened, or asteroid hitting the Earth has done. Like, we have managed to kill our planet faster than anything ever has in its 4.5 billion years of existence, which is depressing. But it's also food for thought. Well, this planet is, how long it's been here before us. Years of life has existed on this planet before we have, and what we've evolved from. It's fascinating and it's beautiful and it's crazy and complex and hard to even grapple with because it's so much for our puny human minds to interpret. But it's also really cool because we are made of the exact same elements that stars are made of. And so the very life elements that the universe has created us, and we're able to observe the universe. It's like Inception. Like, we're observing ourselves. The universe is observing itself through us. If you really think about it. That's a whole other topic that I can get into. And I've like dropped little hints here and there, and I feel like I really need to get into that topic at some point. But all that said is, I believe that science is literally the language that God uses to help us understand itself and understand ourselves. And I think that's so cool. And like, if you don't believe in God or a higher power, like, I totally get people who are agnostic, etc. You can't deny the fact that the science has really cool nuances and facts that make you kind of question, like, interesting coincidence, you know? All that said, we are literally made of star matter. And those trillions of galaxies, 2 trillion galaxies out there with hundreds of billions of stars in them, all made of the same elements that you and I are made of. The galaxy is like a distant cousin. Everybody's just waiting for us to have a family reunion. Like, we just gotta learn it, figure out how to get to it. And I'm hopeful that, I know a lot of people are scared of AI. I don't know if I'm necessarily scared of it. I'm concerned of the impact that it'll have on our environment, but not the technology itself. I think what it takes to have AI will kill our planet faster than anything that the AI could or would do in order for us to cease to exist. And I do hope that we'll be able to have such cool scientific breakthroughs in the time that I'm alive. Like, I hope that AI and the evolution of science in my lifetime allows for space tourism, like allows for us to be able to go to space. Natalia asked me this the other day. She goes, if space tourism existed while you were alive, would you go? I'm like, bro, I would be the first one out of here. I would be, whatever you got to put me on, jetpack, whatever, I'm going. Put me in the universe immediately. Put me into space. I would do it in a heartbeat. It'd be terrifying, but like, I would do it in a freaking heartbeat. I should have been an astronaut. What am I doing? I'm over here just talking to y'all on a camera. Could have been an astronaut floating in space. That wasn't my calling. It's okay. Just yapping about space. But all that to say is that There's so much for us to learn. And there was a really cool quote. I can't remember who said it, but one of the first people to orbit Earth and look at Earth from space looked at it and realized, like, oh, all of our problems, all of the things that are so minuscule. You're like, why the hell does that petty shit matter? Seriously. So I really hope that humanity continues to make investments in space exploration, because I think that there's a lot lying in the science of the universe. This answers to so much about ourselves, because we are all connected, very much so connected. That said, I hope that me nerding out about the universe has given you a new universal and cosmic perspective. I just find it so fascinating. So if you've made it this far, thank you so much for nerding out with me. Thank you for tuning in to the new series of Things Worth Knowing, and I'm so excited to share the next topic that I decide to nerd out about, and I appreciate you listening. Put in the comments below what you want to hear about next. If there's a subject in history or sociology or psychology or anthropology that you're like, I want to hear about this, tell me. And I would love to do research on it and do the next episode in the series on it. But thank you so much for tuning in. This is so fun for me, clearly. Take a second tonight and look up at the stars, look up at the moon, and realize there's so much more out there. And we are just tiny, 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 tiny little part of something so vast that we can't even comprehend it. And it's beautiful. And I will see you very soon. 2 weeks. Bye.